is mutation? Mutation is basically any alteration in the DNA sequence of the cell. So if there's any base pair mistake or alteration or change in the DNA sequence of the cell is what we term as mutation. Now it could comprise of substitution or nitrogenous base, or the insertion of the deletion, or even major changes in the chromosome, in the number and structure or form of the chromosome. Remember, we talked about the number of chromosomes changing leading to two conditions known as aneuploidy and diploidy. Aneuploidy and polyploidy rather. Polyploidy. Alright, so these are major chromosomal mutations. Alright, so what our focus today is on just the gene mutation, the segment of the DNA, that fragment of DNA that changes, not the whole chromosomal mutation. Alright, now what are the causes of mutation? Before we talk about the causes, now the effect of that mutation is based on the cell, the type of cell that is being affected, and that is one of the way we classify mutation. So when we get to the type of mutation, I'm going to talk about that basically. Now, what are the causes of mutation? The causes of mutation could be the pre-cell division stages, such as DNA replication. Or maybe even transcription. So if transcription or replication is done wrongly or with mistakes, then it is mutation. Such as, for example, when DNA replication is happening and there is a base mismatch. So a base mismatch is where, you remember the base pairing that we talked about, that adenine pairs with thymine and guanine pairs with cytosine, and in the RNA we say that this pairs with the uracil because there is no thymine in the RNA, of course. So if there is a change there is a mistake in this transcription or this base pairing, then that could lead to mutation, or that is basically mutation. Alright. Another mistake could be in the cell division. Another cause of mutation could be in the cell division stage, where there is a due to non-disjunction, and non-disjunction could happen as a result of many reasons. All right. So during cell division, in cell division that happens in our cell, non-disjunction could lead to either of this type of chromosomal mutation. All right. And the other cause of mutation is, it could be artificial. It could be based because of radiation, some radiation, or it could also be because of exposure to some mutagen. So if a cell is exposed to radiation, such as X-ray and gamma ray, it could lead to mutation. If you remember the story of Marie Curie, for example, who discovered the X-ray. So when she was, according to the story, she loves to bask in the light of that invention. So, and she didn't know that she was exposing, she didn't know about the danger she was exposing her cells to. So her cells became malignant, cancerous, and then she died. So that is, being exposed to radiation such as X-rays could lead to mutation. Alright, being exposed to some chemicals as well, some carcinogenic chemicals, for example, could lead to mutation of the DNA sequence. Alright, so those are the causes of DNA. Now let's discuss the types of DNA of mutation. Now, mutation can be classified based on several things. For example, it is classified, if we classify based on the cells that they happen to, then we'll have the somatic mutation, somatic cell mutation, and the non-somatic cell, which will be germ cell. You know, our sex cell, or what we call sex cell mutation. Sex cells are also called germ cells. So, or sex cells or germ cell mutation. So, in the somatic mutation, the basic difference is this. In the somatic mutation, the cell, of course, will experience some alterations. I mean, the cell will experience some misnomer, maybe in the size, in the function, in the form of proteins that are, you know, in it, and the rest of that. But the major difference is that it is not inheritable. It is not hereditary. So, note that somatic cell mutations are not hereditary, while germ cell mutation, because they are happening to the cells of the sex cells, which of course makes the new generation, it is heritable. So, for example, after cell division, a particular chromosome of the sex cell becomes mutated. If peradventure or by being unfortunate, that same cell, sex cell, is the one that fertilizes with another cell. Say, for example, the sperm, which is mutated, fertilizes an unmutated egg. Then is going to be the mutation is hereditary. So this one is non-hereditary, while this one is hereditary. So that mutation, that alteration will be carried on to the next generation. Excuse me. And of course, this is where mutation rate actually comes to play. But we're going to talk about it in just a second. Alright, so we said that mutations that happen to the germ cell are hereditary, and the degree of its of the inheritance, once it has been transferred or inherited by one generation, the degree of the inheritance begin to expand divergently. Alright, so what happens is that since one individual has already claimed that mutation, it is possible that it happens there's a higher tendency of that person carrying that mutation in his or her own germ cell again, and then it becomes transferred onto the next generation and the propagation continues. Right? So in the somatic cell mutation, we said that they are non-hereditary. So of course it's going to affect the cell of the body. Let's say in the arm, maybe the cells of the arm are exposed to radiation, and then a particular mutagen, and then mutation occurs. Maybe the cell become malignant and lead to other things. That is not inherited. That is not hereditary. All right. So now, how about so this is classification based on the cell that is being affected. So how about classification that is based on the cause? The cause. So based on cause, we classify them as spontaneous mutation, and induced mutation. Spontaneous mutation is one based on, as the name implies, when a reaction is spontaneous, means it happens on its own. It happens on its own, all right? So it doesn't require any external force to make it happen. All right? So spontaneous mutations are the ones that take place on their own, and their causes are usually untraceable. So, for example, it could be a mistake in the DNA sequence, such as a missubstitution of one of the nucleotide sequence. So, spontaneous mutations are usually untraceable. That is the point. They are usually untraceable. While the induced mutation are the ones that are typically caused by artificial, when you causes, such as exposure to radiation that we talked about, or exposure to a particular mutagen. All right, so that is an induced mutation, while spontaneous mutation is the one that happens naturally on their own. And the probability of this happening, which is the mutation rate, is usually very low. And in fact, let's okay, let's finish talking about the types of mutation. So those are the according to the causes. All right. We could also classify mutation according to their molecular change, their effect on the molecular changes of the DNA sequence. So we could classify them as point mutation, Now, a point mutation is one that, now, we talked about substitution, we talked about insertion, we also mentioned deletion. Alright, so these three basically can happen and lead to this. Alright, so point mutation is when either of these three, substitution, insertion, or deletion, happens to one of the base pairs, only one of the base pairs of the DNA sequence. Now I'm going to use an example that is without the letters of the standard letters of this nucleotide sequence, nitrogenous bases. And I'll still use the nitrogenous base as an example. But consider the example. For example, look at the letter. The nucleotide sequence acts in triplets that we call codons. All right. So those triplets are the letters I'm going to use. So consider this letter, this sentence, for example. So this is one codon, meaning 3 nucleotide sequence. The cat eats the rat. Let me write it clearly. For example, the cat eats the rat. Alright, so for example, this is the sequence. These are the codons of let's say for example, the DNA. Now, the RNA polymerase wants to transcribe this. Alright, if this is the messenger RNA, if this is to be transcribed into the messenger RNA, now, if there is a mistake such as a change in one of these sequence, for example, if in that system of when it is being transcribed into the messenger RNA, we have, for example, D is still here, but instead of this, we now have a change such as the C changing into an R, and then A-T, and then we still have E-A-T, the rat. So look at the sentence has changed. From the cat eats the rat, then it has changed to what? The rat eats the cat. Alright? The rat eats the cat. Let's use a more correct sentence. So let's use something like ate, for example. Because structurally or grammatically it's supposed to be the cat eats the rat. So let's use the past tense, which is still basically correct. Alright. So look at this. The cat ate the rat, and because the C has been altered, so this will be called a wrong substitution, and this is a point mutation. Why? Because it is happening only to one of the portions of the codon, one of the nucleotide sequence, one of the nucleotides of the codon. So you see, only this R, one of these nitrogenous bases, is changing. So it is called a point mutation, and it is a wrong substitution. Alright? It could also be a deletion. Now, a deletion usually leads to what is called the frame shift mutation. The frame shift mutation. Now, in the frame shift mutation, what happens is this. I'm still going to use this same letter sentence. So, in the frame shift, now this sequence could be that there is a wrong insertion or a deletion of one of the sequence. If it is an insertion, for example, it could happen that one has been wrongly inserted. So we now have if nitrogenous base is mistakenly inserted here, for example, you now have something like this. Now, the sequence is supposed to be the cat. So let's say we had an X. The cat ate the rat. Now, this cannot happen for the system of coding. It has to be in triplet. So because of that, then we now have the cat. This now becomes this because of this S. You know, S was added here before. S was added here. So this S will now pair up with this and will pair up with S was added here. So this will now pair up with AAT and become SAT. The cat SAT. Then this becomes ETH, F, then ERA, and then T plus another sequence of codon in front. Alright, so you see that there is a total difference now. The cat, SAT, F, ERA, T, and it doesn't make sense again. So because of this, there is an insertion, or maybe even a deletion of one. So if one is being deleted, for example, if this is being deleted, or let's say this was being deleted, the C was being deleted, then we now have D still. We still have D is still there. So we have D, for example, AT. Remember the S wasn't there. So AT maybe A, and then TE, T, and then HER, and then AT. So you see that the sequence has totally changed. Why? Because that's why it's called a frame shift. Because one was added here, and then the sequence has to be coded in triplicate. So they had to change. The system had to. That's why it's called a frame shift. The system has to shift such that they still code, they still pair, they still come together in triplets. So the codon sequence changes. Alright, so that is a frame shift mutation. A frame shift mutation. Alright. Now, based on the effect that it produces, that either of these ones produce, either of these side of mutation produce, we also have the excuse me. We also have the missense, excuse me. We have the missense mutation and the nonsense mutation. So we've discussed all of this in the 100 genetic sense that we talked about. The missense mutation is this. If a deletion or a substitution, or usually a substitution, if a substitution leads to the coding, leads to another amino acid being formed, you know, when the mRNA, when the DNA is being transcribed into the mRNA here, if you don't understand all of these things, I will enjoy you to go and watch the video on DNA transcription actually here. So when the mRNA is being the DNA is being transcripted to mRNA, and the mRNA goes to the ribosome for the tRNA to transcribe to match it with the appropriate amino acid. If the because of a change such as a substitution in one of these nucleotides, because of that substitution, the amino acid that is being coded for changes, then it's going to be called a missense mutation. So, for example, if we have the AUG, which is usually the start codon for every transcription, coding for methionine, if it changes to, let's say for example, this AUG, this is supposed to be methionine, changes to, let's say there is a mistake and maybe the U is being substituted for a G, maybe a G, for example. You have a GG. This is another amino acid. This codes for another amino acid entirely, no longer methionine. Okay? Then in the nonsense mutation is when that particular DNA sequence actually now codes for a stop codon. A stop codon. Alright, so for example, an example of stop codon is UAG. You see, basically is a rearrangement of this one. Alright, so if this is a stop codon, so if a particular sequence now mistakenly codes for maybe it was actually C, for example, which is supposed to be a methionine, a start codon that was there, and mistakenly changes this, substitutes this C, cytosine, for guanine. This is a stop codon, so the system immediately gets truncated. So the transcription gets truncated, it gets stopped immediately. So that is why it is called a nonsense mutation. Alright, based on this substitution, we also have that if a purine is being substituted for a purine, or a pyrimidine is being substituted for a pyrimidine, then both will be called, the kind of substitution that happens there is a transition, while if it is a pyrimidine for a purine is being changed to a purine, then that substitution is called a transversion. A transversion. Alright? So those are basically the types of mutation. Now, what is a mutation rate? Mutation rate is basically the probability or the possibility of a particular gene being mutated. So, and for spontaneous mutation, the mutation rate is usually very low. Alright? So, mutation rate, while for induced mutation, which are exposure to X-ray and the rest, is more likely to occur than spontaneous mutation. And this is the reason. You know, spontaneous mutation are basically mistakes in the DNA replication. When we talked about DNA replication, we talked about the fact that there are factors in the system, in our system of the cell, that such as some proteins that actually go back to check for correction of that DNA replication or transcription process to make sure that there is no mistake, no error. So because of that, spontaneous mutations are the mutation rate of a gene for spontaneous mutation is very low, in fact extremely low, while induced mutation is most likely if the person is being exposed to radiation or a mutagen. So that brings us to the end of the video. Do well to subscribe to the channel and click on the bell notification to get notified whenever we drop a new video. God bless you.